All right, guys, let's finish this up. So this is the last half. So our first element here is H. Our second is O. Now, let's identify whether they are metals or nonmetals. Oops, I need the table. Now, hydrogen, remember, he's in group 1 because he has 1 valence electron, but he is green, he is a nonmetal. So even though he is in group 1, he is the exception, he is a nonmetal. So hydrogen's a nonmetal. Oxygen is also a nonmetal. So, nonmetal, nonmetal. Now we know that bonds between two nonmetals are covalent, okay? And, we know that the naming rules tell us we need our prefixes, because remember the covalent naming rules are different than the ionic. If it was ionic, we would just name the metal, then name the nonmetal and change it to IDE. But here, because it's covalent, we need our prefixes. So 2, we need to find the prefix for 2, which is di. So we're going to have dihydrogen. And here we have 1 oxygen. And so here, because it is the second element, so not the first, but it's the second element, here 1 is mono. So this is going to be monoxide. So dihydrogen monoxide. And yes, I know that you know that the common name for this is water. That's an example of a compound name that you would know the answer of or the name of without having to Google. So like a lot of these, when we're talking about, don't Google because they might have a different name than what we're doing with the naming rules. Water is not an example of that because I know that you guys know that H2O is water, right? That's not something that I was like, oh, you said water and not dihydrogen monoxide. You must be cheating. No, I know it's water. You know it's water. If you put water, that's okay. Okay, but if I specifically ask you to use the naming rules and not the common name, it would be dihydrogen monoxide. Okay, all right. K is potassium. O is oxygen. We know that oxygen is a nonmetal. Let's look for potassium. Potassium's right here. Again, he is in group 1, so he is a metal. And he's not a nonmetal, so we don't need the Roman numerals, okay? We don't need the Roman numerals. So it is a metal. We know a bond between a metal and a nonmetal is the transfer of electrons, which is ionic. And again, our naming rules, we name the metal first. Then we name our anion, aka our nonmetal, which is oxygen, and of course we change it to oxide, so potassium oxide. Again, I noticed some of you guys were putting a charge on potassium, like you were putting the Roman numerals, like you were saying, oh, it's potassium 1. It's not. Nope, just potassium oxide, because potassium is not a transition metal, right? Go to the table, transition metals. Oh, is potassium in the pink? No, he doesn't need a Roman numeral, okay? All right, aluminum. Fluorine. Fluorine is a nonmetal. Aluminum is a metal. Don't believe me? Let's look. Aluminum. He's a metal. He's not pink. He's not pink. I saw a lot of you guys putting aluminum 3. The charge is 3. Yes, 3 plus for aluminum. But it's not a transition, so you do not need the Roman numerals. Okay, so aluminum is a metal. What was the second one? Oh, fluorine. Fluorine is a nonmetal. Okay, so metal and nonmetal, we know that's going to be ionic because, again, between a metal and nonmetal is ionic. Again, let's name our metal first. Aluminum, or if you're from England, aluminium. You are not, so do not say that. And then our second one is fluorine. So fluoride. Okay, so again, we changed the I and E to IDE. All right, I did copper 2 chloride for you guys in that original video. So if you go back to the lesson and watch the original 2 examples, it's there. This is the one with a transition metal. Again, you know that it's copper 2 because this 2 subscript came from the original charge of copper, so you just work backwards for that. And it would be copper 2 plus, right, because it's a metal, so it's always a positive charge. But again, you know, if you were going to do this, we find copper. Copper's right here. He's a pink. He's a transition metal. Now we have to have the Roman numeral, okay? The transition metal you have to have for Roman numerals. And I do apologize if I did not make that clear in your original video, because I'm assuming that you guys watched that video and then assumed all metals needed the Roman numerals. No, it's just for the transition metals, okay? So that's where we got the copper 2 chloride. Okay, let's do our last one. C, carbon, chlorine. Carbon is a nonmetal. Chlorine is a nonmetal. Don't believe me? Let's look at the table. Carbon, green, nonmetal. Chlorine, green, nonmetal. Okay, so this is covalent. Geez, Mrs. Conn, would be really good if you could spell right. Okay, covalent, right? So we have 2 nonmetals. This would be a sharing of electrons. This is a covalent bond. Here we have our naming rules for covalent compounds, not ionic compounds. They're 2 different steps, so just make sure you know the difference. All right, here, so immediately when you see that it's covalent, think prefixes, okay? Ionic, no prefixes. Covalent, you need a prefix, okay? Here it's 1 carbon, right? If it was the second element, we would say monocarbide or whatever, but because it's the first element and it's only 1, we just write the name of the element. So carbon, carbon, okay? There's 4 chlorine. 4 is tetra. So this is carbon tetrachloride, okay? And that is it. So again, chlorine, I and E changes to IDE. You're always changing the ending to IDE, whether it's ionic or covalent, unless it's a polyatomic. Remember, with your ionic bonds, polyatomic ionic bonds, then it would be either 8 or ite or hydroxide if it's OH, cyanide if it's CN. You just have to use the table for those. None of these were polyatomic, so this is just seeing if you could identify the bonds and then name them. So again, remember with the metal, you are naming the metal first, then the anion, aka the nonmetal, you're changing the ending to IDE. If it's a transition metal, so if it's one of the metals in the pink, then it gets a Roman numeral for the charge. The reason for that is because the transition metals can vary in their charges. Metals in groups 1, 2, 3, they don't vary in their charge numbers, but the transition metals can. That's why we have to give them a Roman numeral, okay? And then for your covalent, again, you have to make sure you are using the prefixes, right? So we pay attention to how many atoms there are. That tells us the prefix. So like 1 is mono, 2 is di, etc., etc., okay? And of course, if it's just 1 for the first one, then you don't have to do mono. So like we didn't have to do monocarbon here. But if it's the second one, like an H2O, you do have to say mono, so monoxide. So that's the rundown. I hope this helped. If not, let me know. We can do it together on Zoom.